Hello everybody. In this video, since we have welcome to our class on writing equations of lines. So we've graphed them, but now we're going to be given information about our lines and we need to write the actual equation, usually in y equals mx plus b form. We're looking for that slope-intercept form for our answer, where y will stay y and x will stay x, but we need to find m and b. M, once again, is our slope, and b is the y-intercept. Okay. This is going to come across in four different possibilities. They might give us a slope and the y-intercept, in which life is really cool because we just plug those numbers in. But most likely they're going to give us either a slope and a point, or they're going to give us 2 points, or they're going to give us a point and then they're going to talk about another line and they're going to be having a relationship there. So we'll talk about all of those things hopefully in this 30-minute video. The first one, write the equation of a line with a slope of -3/2 and a y-intercept of 7. Again, we just want to fill in our blanks of y equals mx plus b. So y has to stay y because it's going to change throughout. We need to represent all of those xy pairs that make the line. But we just fill in. We know that the slope is -3/2, and that's what m is. So we're going to put -3/2 in for that, x, and then plus our b value, which is the y-intercept. The y-intercept is 7, so we just plug that in. And bada boom, bada bing, bada bang, we've written an equation of a line in our slope-intercept form. It's okay that there's a fraction there. Remember, fractions are kind of our friends when it comes to slopes, and so it's okay there. So that's technique number one. No problem. Just fill in the gaps. The second one, they might tell us to write an equation of a line, and they're going to give us a slope, and they're going to say that the line passes through this point. That's giving us essentially a second value so that we can write our equation. But again, I need to know my slope and the y-intercept. Now, the y value here, -5, is not the y-intercept. Remember, the y-intercept is a specific value. It's the y value only when x is 0. That's how you stay graphed on the y-axis, is we didn't go left and right. If we were to plot this point 4, -5, we'd be over 4 and down -5. That's not the y-intercept because it's not on this y-axis. Okay? So remember, just because there's a y value does not mean it's the y-intercept. The y-intercept is only if they give you a point, 0, and some number. Then it's the y-intercept. In this case, then, how do we write the equation of a line? Well, we've talked about having the slope-intercept form, which tells us the slope and the y-intercept of a graph. That's that y equals mx plus b. But today we're going to learn a second one called the point-slope form. And the point-slope form is used when you're given a point and the slope. And the point-slope form is y minus y sub 1 is equal to m times the quantity of x minus x sub 1. Where x and y are the x and the y that have to stay in the equation to represent all of your solutions, all of those pairings that make the left side equal the right side. The x sub 1 and the y sub 1 is the given point. So this is x sub 1, y sub 1 up here. And of course the slope is our m. So once we have that, we just plug that in to the point slope form. So we're going to have y minus my y value, which is a -5. Now that's separate from the subtraction. The formula says y minus my y value. I'm subtracting, in this case, my y value is a negative, so I'm subtracting a negative, is equal to -9 times the quantity of x minus my x value, which is 4. Now, if you just wanted to clean this up, simplify a negative or subtracting a negative is the same thing as adding a positive, you'd end up with this. Now, this would be your answer if they wanted it in point-slope form. However, if they want it in slope-intercept form, you now have to just do a little simplifying of the math. So the first thing you're going to do is use your distributive property here so that you can see all of your terms. Remember, a negative times negative will make that a positive 36. And then get y by itself by subtracting the 5. Write that over here. We have y equals negative 9x plus 31. And that would be your answer in slope-intercept form. So if they ask for it in slope-intercept form, you just have to simplify it and solve for y. If they want it in point-slope form, you just make sure that you clean up any subtracting of negatives or things of that sort. So again, if they ask to write the equation of a line and they give you a slope and a point, you want to use the point-slope form. The next method, they might tell you to find the equation of a line, but they're going to give you 2 points. So in this case, they do not give you the slope. However, we have a formula for slope. The formula for slope is y2 minus y1 all over x2 minus x1. So since we were given 2 points, we can find the slope by plugging in the slope formula. So doing that, we'd have m equals 45 minus 3. Remember, it's not alphabetical. You have to do your y's, which are your second values first. I started with the 45, so I have to start with the negative 7 next to it, minus, now I'm subtracting a negative 1. So 45 minus 3 is 42. Negative 7 minus a negative 1 is negative 7 plus 1. So it's going to give me a negative 6. Simplifying that, dividing it out, 42 divided by negative 6, my slope is negative 7. Now that I have a slope, I can pick either of the points and use my point-slope form. Again, the point-slope form is used when you have a point and the slope. It does not matter which point you use because the equation has to go through both of them, so it's going to make it true no matter which point you use. In this case, though, I would use negative 1, 3 because the numbers are smaller and now less likely to make a boo-boo. So now that you have the slope, take the slope and a point and plug it into the point-slope form. Remember, the first variable, x and y, are the ones that stay x and y. It's the second ones with the little ones that represent the point that was given to us. So we have y minus my y value of 3 is equal to the slope, which we solved for, of negative 7, times the quantity of x minus my x value, which is a negative 1. Lack of space, I'll do a little cleanup right here in the same line. Subtracting a negative, same thing as adding a positive. Now I'm going to use my distributive property to get rid of parentheses, because again, that would be my answer in point-slope form, but usually they want it in slope-intercept form. Slope-intercept form has y by itself on one side and everything else on the other side. So we'd be at y minus 3 is equal to negative 7x. Now remember, this ends up simplifying to a positive 1, so negative 7 times that positive 1 is a negative 7. And then finally, to get y by itself, we just add the 3 to the other side. Add it under the like terms. I get y equals negative 7x minus 4. And that's my answer in slope-intercept form. That's why you need to know those forms, which one's the slope-intercept and which one's the point-slope, so that you can answer the question correctly. This is just studying it, reviewing it, writing it over and over. That's how we remember these things. We don't just assume that we're going to know it, or we don't just say, oh, who cares? We have to put that time in to find it. Here is what my point slope looks like in blue, and in red would be my answer in the slope-intercept form. So again, if they give us 2 points, we can find the slope because we have a formula for that. Once we have the slope, you just pick one of your points and use the point-slope form, and then simplify it. Now the last technique says that we're going to have some relationship with another equation. But before we can dive into that, we need to talk about lines and how lines can be related to each other. One of the things that lines can be is they can be parallel lines. And parallel lines never intersect. And for lines to never intersect means that they're going to have to rise and run at the same rate. That's why they never cross, is they're always rising and running the same rate, so they're never getting any closer to each other. So in parallel lines, the slopes are the same. So if I said, write the equation of a line that goes through this point and is parallel to this line, we'd have to find the slope of that line and then use that same slope. They also, they also gave us a point. So use that same slope with the point that they give us in the point slope form and simplify, and we're all done. Perpendicular lines are a little bit more involved because the slopes aren't the same in perpendicular lines. In perpendicular lines, the lines cross each other at 90-degree angles. So they're not just randomly hitting each other, they're hitting each other at 90-degree angles. That's what makes them perpendicular. So that's what makes perpendicular lines special, is they're intersecting at 90 degrees, which are also known as our right angles. Now, in order for that to happen, the rise and the run not only are opposites, because one has to have a positive slope and one has to have a negative slope, they're also flipped of each other, called reciprocals. So the slopes of perpendicular lines are negative reciprocals. And again, what that means, negative means that one's positive and one's negative, so they're opposite signs of each other. And reciprocals is just your flipped fraction. So for example, if I found a line to have a slope of 2/3, the slope of the perpendicular line would then be, and the symbol for perpendicular is an upside down capital T looking like shape, because it's a vertical and a horizontal line that hit at a 90-degree angle. So M with a little sub symbol to let me know it's the perpendicular. We flip it around so the bottom goes to top, top goes to bottom. It was positive, so we make it negative. So if I was once again given a line and found that the slope of it was 2/3, and I need to write an equation of a perpendicular line, the slope I would use is -3/2. Let's do another one of those. So if I had a line in which the slope was -4, then the slope of the perpendicular, remember -4 doesn't look like a fraction, but they're always fraction because you can always put it over 1. So the flip of that is going to be 1/4, and then negating a negative makes it positive. So the slope would be a positive 1/4. Those are examples of finding perpendicular slopes. Again, they're going to give us a problem like this next one. Find the equation of the line that goes through this point, -27/8, and is perpendicular to the line with the equation -9x minus 4y equals -12. So again, in order to write an equation of a line, I need a point and a slope, so I can use the point-slope form. Even if I was using the slope-intercept form, I still need to have a slope. No matter what, the first thing you're always looking for is a slope. So the only way I can find a slope here is by rearranging this equation. So if I solve that equation for y so that it's in the form of y equals mx plus b, I can easily identify the slope because it's going to be the number in front of my x. So that's my goal in this equation, is to rearrange it so that I solve for y so I can find the slope. The first step in doing that is to get the term with the variable by itself. So I'm going to add the 9x to the other side to get the y term by itself. Negative 9x plus 9x goes away. Negative 4y is equal to. Now, negative 12 plus 9y. Those are not like terms, so I can't combine them as they are. But I do want, oh, that's an x, sorry, 9x. But I do want to put the term with the variable first. So the 9x goes first. Oopsie. Minus 12. The sign in front goes with it. My apologies there. I was looking at my next step. So now I need to get the y by itself, so I need to get rid of the negative 4. Again, negative 4 dot y, or is right next to the y, which means that it's multiplication. So I have to divide to get rid of it. It's not a subtraction, it's a negative number being multiplied to the y. So I'm going to divide by negative 4. Whenever you multiply or divide, you have to divide every term, whether it's going to make a pretty number or not. Adding and subtracting, we only add and subtract like things, but multiplication and division happen to everything. So now we simplify here, we get y is equal to negative 9/4 x, and a negative divided by a negative is a positive. 12 divided by 4 is 3. So another way to write this equation is y equals negative 9/4 x plus 3. That's the same thing as this equation up here. I just wrote it differently. And I did that so I can identify the slope. So the slope of this line is negative 9/4. Okay. Now again, I need the perpendicular line. So the slope of this line is negative 9/4. But because I'm writing the slope of the perpendicular line, I need the negative reciprocal of that. So the slope that I'm going to use is going to be a positive 4/9. Switch the sign from negative to positive, switch the bottom to the top. Now that I have my slope and a line and a point that it goes through, I can use my point slope form. I suggest that you rewrite these equations, these forms, every time you're going to use them before you plug the numbers in. For one, it puts it into memory, and for two, you'll make fewer mistakes because you have it right up there. So now it's y minus my y value, which is the 8, equals 4/9 times x minus my negative 27. Do a little cleanup here. Subtracting a negative is the same thing as adding a positive. Then we get rid of our parentheses. So again, this would be my answer if they told me I wanted it in point slope form. In point slope form, it would be y minus 8 equals 4/9 times the quantity of x plus 27. So make sure that you just rewrite this as just a single plus sign if they wanted point slope form. If they then wanted slope intercept form, which is this form up here, we then have to simplify this. In order to do that, we have to get rid of the parentheses first, which is done by using our distributive property. So we'd have y minus 8 is equal to 4/9 x plus, and now I have to take 27 times 4/9. If I go over here on the side, 4/9 times 27. The key to realize here is that 27 is a multiple of 9. 9 goes into 9 once, 9 goes into 27 3 times. So we end up with just a 1 in the denominator, which means that we don't have an ugly denominator at all, or an ugly fraction anymore. And I'm just left with 4 times 3, which is 12. And then finally, we just have to add the 8 to the other side to get our answer in the correct form. Y equals 4/9 x plus 20 would be the equation of this line in slope-intercept form. And again, up here, this would have been the point-slope form. So make sure that you read the directions carefully as to how they want you to write your answers. So those are your procedures to writing equations of lines. Again, they're either going to give us a slope and a y-intercept, and we plug it in for the correct letters. The m goes in front of the x, and the b stands alone. Or they're going to give you a slope and a point, where you can plug it into the point-slope form, replacing the slope with m, and then the point is your x1 and your y1. And again, x and y have to stay in there to represent all of the pairings that make the left side equal the right side. So again, just writing it in point-slope form, they might just want it that way, or they're going to ask for the slope-intercept form, where you just have to multiply through and solve for y. The third way, they might just give you 2 points. Well, we know how to find the slope if they give us 2 points. We plug it into the formula for slope. Once we have the slope, we take that with one of the points, it doesn't matter which one, just make sure it's the same pairing together, and plug it into the point-slope form again. And then finally, they might throw some other words at us for us to understand relationships that lines have. Lines might be parallel or they might be perpendicular. They might not be either of those, but they could be. If the lines are parallel, you need to know that the slopes are going to be the same. If lines are perpendicular, the slopes are negative reciprocals. Flip it over and change the sign. And in that case, again, you might have to do a little manipulation first. So this is what we did over here first of all, was find the slope by rearranging that equation. Find the perpendicular slope that we need on that. And then again, once you have a slope, you can choose the point, and with that point and the slope, plug it into the point-slope form and simplify. Those are your techniques in order to solve or to write equations of lines. So make sure that you pause and play this over and over again. Pause it, make some notes, so that you can then relate it to your exercises and practice, practice, practice. See you next time.